Somewhere in the cold silence between Earth and Mars, there is a question that has quietly haunted engineers for generations. Not how to reach the red planet. Humanity already understands that part. The deeper mystery is how anyone could ever come back. Mars does not easily release what lands upon it. Its gravity holds tightly. Its thin atmosphere works against you. And the immense distance between worlds turns every return journey into a slow and unforgiving gamble against physics itself. Tonight on Velarin's Sleepy Space Mysteries, we will drift through the hidden mechanics behind one of the greatest engineering problems ever imagined. And if you enjoyed our earlier journey into the strange loneliness of deep space survival, you may notice tonight's mystery feels connected to that same quiet cosmic tension. Before we begin, take a moment to subscribe, leave a like, turn on notifications, and if you wish to travel deeper into these slow cosmic mysteries, you can also join the channel membership. And somewhere out there beneath tonight's stars, tell me this: where are you watching from tonight? Perhaps from a quiet city apartment, perhaps from a countryside wrapped in rain, or perhaps from somewhere awake long after midnight while the rest of the world sleeps. Because tonight we are going to follow a path few people truly understand. A path shaped not by hope or ambition, but by gravity, fuel, orbital timing, and the ancient mathematics that govern every moving world in the solar system. Most people imagine Mars as a destination, a lonely red horizon waiting for the first human footsteps. But engineers often see something very different when they look at Mars. They see a trap, not because Mars is impossible to reach. Humanity already knows how to cross interplanetary space. Robotic spacecraft have been doing it for decades. The real terror begins after landing, because the moment a human crew touches the Martian surface, an invisible countdown quietly starts ticking above them in the sky. The planets continue moving. Earth continues racing around the sun. Mars drifts onward through its colder and slower orbit. And hidden inside those motions is a brutal truth. You cannot leave Mars whenever you choose. The solar system decides when you may come home. This is one of the strangest psychological aspects of a Mars mission. Even if the astronauts survive the landing perfectly, even if their habitats work flawlessly, even if their food systems and life support remain stable, they are still prisoners of orbital mechanics. The return window is not flexible, cannot be negotiated with. It appears only when Earth and Mars align in exactly the correct geometry. And those alignments happen roughly once every 26 months. Imagine standing on another planet knowing your ride home depends entirely on the position of worlds moving hundreds of millions of kilometers through space. Because Mars and Earth orbit the Sun at different distances and different speeds. Earth moves faster, Mars moves slower. Over time, the two planets drift into constantly changing arrangements. Sometimes they sit relatively close together on the same side of the Sun. Other times they are separated by immense distances with the Sun itself lying between them. The difference is enormous. At their closest approach, Earth and Mars may be separated by around 55 million kilometers. At their most distant, they can be more than 400 million kilometers apart. This changing geometry controls everything about interplanetary travel. A spacecraft cannot simply launch straight toward Earth like an airplane flying between cities. Space travel does not work that way. Every spacecraft leaving Mars also orbits the Sun. It follows a curved path shaped by gravity. Mission planners must predict where Earth will be many months into the future and launch the spacecraft so precisely that both worlds arrive at the same point at exactly the same time. It is less like steering a vehicle and more like throwing a needle across a moving carousel while both the thrower and the target are spinning through darkness. The most efficient method for making this journey was developed over a century ago. It is called the Hohmann transfer orbit. The idea is elegant and strangely beautiful. Instead of constantly firing engines throughout the journey, the spacecraft performs one major burn to leave Mars and enter a long elliptical orbit around the Sun. Then it simply falls through space for months, quietly coasting through the darkness while gravity guides it toward Earth's orbit. Near the end of the journey, another engine burn slows the spacecraft enough to meet Earth safely. This approach saves enormous amounts of fuel. And fuel is everything. Every kilogram matters. Every unnecessary maneuver becomes another burden carried all the way from Earth. But the Hohmann transfer comes with a price: time. The journey takes roughly 7 to 9 months each way. And more importantly, it only works during narrow launch windows. Miss the window and the fuel requirements become vastly larger. A mission already balancing on the edge of physical possibility suddenly becomes impossible. This creates the terrifying waiting problem. A crew arriving on Mars cannot simply finish their work and leave. Most mission designs require astronauts to remain on the Martian surface for over a year before the planets align correctly for the return trip. 14 months, sometimes longer, not because scientists want an extended vacation on Mars, but because the laws of orbital mechanics demand it. During that time, the astronauts must survive on a hostile world where temperatures plunge far below freezing. Dust storms can darken the sky for weeks. Radiation quietly damages living tissue, and Earth appears only as a distant point of light hanging in the blackness. The loneliness of that reality is difficult to fully imagine. Apollo astronauts on the Moon were only days from home. Mars astronauts would be trapped by distance itself. And perhaps the most unsettling part is this: if something goes wrong with the return vehicle during the launch window, the crew may have to wait another 26 months before trying again. More than 2 additional years stranded on another planet because the celestial timing no longer works in their favor. No rescue mission could arrive quickly enough to save them. No emergency evacuation exists. Once humans travel to Mars, they enter a level of isolation unlike anything humanity has ever experienced. The universe itself becomes part of the mission. And the universe does not hurry for anyone. The deeper engineers studied Mars missions, the more they realized something unsettling. The challenge was not only about reaching another world. It was about surviving long enough for the solar system to allow you to leave again. Every kilogram of food, every liter of water, every spare component inside the habitat suddenly became part of a gigantic equation shaped by time itself. Because once astronauts arrive on Mars, they cannot simply decide to come home early. They are locked into a schedule written by orbital mechanics millions of years before humanity even existed. This changes the entire philosophy of space exploration. On the International Space Station, astronauts are never truly isolated. Supplies arrive regularly. Crews rotate in and out. Emergency evacuation vehicles remain docked nearby. Even the Moon, despite its distance, still allowed Apollo astronauts to return home within only a few days. Mars is something entirely different. Mars is commitment. The moment a crew departs Earth, they enter a mission lasting nearly 3 years. 7 to 9 months traveling outward through deep space. More than a year surviving on the Martian surface. Then another long journey back through the dark between planets. And during almost all of that time, there is no rescue. No replacement spacecraft waiting nearby. No possibility of quickly aborting the mission. If something breaks, the crew must repair it themselves. If someone becomes seriously ill, there is no hospital beyond the thin walls of the habitat. Every decision becomes heavier because the distance itself removes humanity's usual safety nets. Even communication changes in strange and unsettling ways. Most people do not realize that Mars astronauts would never have real conversations with Earth. Radio signals travel at the speed of light, which feels instant in daily life. But space is unimaginably large. Depending on where Earth and Mars sit in their orbits, a single message may take anywhere from 4 to 24 minutes to travel one way. That means a simple exchange can stretch into nearly an hour. Imagine a life support emergency inside a Mars habitat. Alarms sounding, oxygen pressure falling, engineers on Earth trying to help. By the time Mission Control even hears the distress call, the crisis may already be unfolding beyond recovery. The crew cannot depend on Earth to save them in real time. They must become completely autonomous. In many ways, Mars astronauts would resemble sailors crossing ancient oceans centuries ago. Once they left shore, they were largely alone. But even those explorers remained on Earth beneath the same sky as everyone else. Mars crews would exist on another planet entirely. During certain alignments, communication becomes even worse. Sometimes the Sun itself moves directly between Earth and Mars. During these periods, called solar conjunctions, radio signals passing near the Sun become distorted by its turbulent outer atmosphere. Communication may become unreliable or impossible for days or even weeks. Think about the psychological weight of that silence. Human beings standing on another planet while all contact with Earth temporarily disappears. No voices from Mission Control. No messages from family. Only the sound of machinery circulating air through the habitat while outside the Martian desert stretches endlessly beneath a pale sky. This isolation forces engineers to think differently about every aspect of the mission. Every tool must be reparable. Every system must include backups. Crew members cannot specialize too narrowly because anyone may need to perform emergency medical procedures, repair power systems, or diagnose software failures. The astronauts must become mechanics, doctors, engineers, geologists, and survival experts all at once. Humanity has never before demanded such broad self-reliance from a space crew. And still the risks continue multiplying, because the longer mission duration creates another invisible enemy, where machines slowly degrade over time, seals become brittle, dust infiltrates equipment, radiation damages electronics molecule by molecule. A Mars habitat must function continuously for years in one of the harshest environments humans have ever attempted to survive in. Fine Martian dust is especially dangerous. It is electrostatic, abrasive, and extremely persistent. During the Apollo missions, astronauts discovered lunar dust sticking to everything. Damaged seals, irritated lungs and eyes, contaminated equipment. Martian dust may prove even worse because global dust storms can engulf the entire planet for weeks at a time. These storms do not have the violent winds of Earth because Mars has such a thin atmosphere, but they fill the air with fine particles that settle into machinery and coat solar panels. Engineers fear this dust because a Mars mission depends completely on reliable systems. Even small failures can cascade into larger disasters when spare parts are limited and help is millions of kilometers away. And through all of this, the return rocket waits silently nearby, perhaps standing on landing legs outside the habitat, perhaps partially buried beneath drifting red dust. It becomes the most psychologically important object on the entire planet, because every astronaut knows the same thing. If that vehicle fails, Mars stops being an expedition and becomes a prison. The return rocket is not simply transportation. It is hope made physical. Yet even that rocket depends on impossible precision. It must survive the landing intact, survive months or years of exposure on Mars, maintain cryogenic fuel systems, keep electronics functional through brutal temperature swings, then finally ignite perfectly on the first attempt. There are no second chances on Mars. No nearby launch pad with another rocket waiting. One ignition, one ascent, one opportunity to climb back into the sky before the planets drift apart again. There is another layer to the Mars return problem that feels almost cruel in its simplicity. Even if humanity solves the fuel problem, even if astronauts survive years of isolation, even if the return rocket remains fully operational beneath the freezing Martian sky, the human body itself may no longer be ready to come home. Space quietly changes people. Changes bones, muscles, blood circulation, vision, even the structure of the brain. And a Mars mission would expose astronauts to these effects longer than any human journey in history. On Earth, gravity constantly pulls against the body. Every movement strengthens muscles and bones because the skeleton is always supporting weight. But in space, that force largely disappears. Astronauts aboard the International Space Station float continuously in microgravity. At first, it seems almost magical. Effortless movement, objects drifting peacefully through the cabin. But over time, the human body begins adapting to this strange environment in dangerous ways. Muscles weaken because they no longer need to support body weight. Bones slowly lose density because the skeleton no longer experiences constant stress. The body becomes optimized for weightlessness, and this adaptation happens surprisingly fast. Studies aboard the ISS have shown astronauts can lose around 1 to 2% of bone density per month despite exercising for hours every day. Muscles shrink. The cardiovascular system changes because fluids no longer settle downward under gravity. Even the shape of the eyeballs can alter due to fluid shifting toward the head. Now imagine extending those effects across a mission lasting nearly 3 years. During the long transit to Mars, astronauts would spend 7 to 9 months in microgravity. Then they would arrive on Mars where gravity is only about 38% of Earth's. Better than weightlessness, but still far weaker than what the human body evolved to handle. After more than a year living in partial gravity, the crew would then spend another 7 to 9 months returning through deep space. By the time they approach Earth again, their bodies may have spent well over 2 years away from normal gravity. Nobody truly knows what that level of exposure would do to human physiology because no one has ever experienced it. The longest human space missions have lasted around a year. A Mars mission pushes far beyond that boundary into largely unknown territory. And there is something deeply unsettling about realizing the return journey itself may become physically overwhelming. Imagine astronauts surviving every danger of Mars only to struggle standing upright when they finally reach Earth again. Returning astronauts from the ISS often require assistance leaving their capsules after only several months in orbit. Some feel dizzy or nauseated because their balance systems must suddenly readapt to gravity. Walking becomes difficult. Simple movements feel strangely heavy. Now extend that adaptation period across years instead of months. The body may begin forgetting Earth itself. Radiation creates another invisible threat. Earth is protected by a powerful magnetic field called the magnetosphere. This invisible shield deflects many dangerous charged particles streaming from the Sun and deep space. Low Earth orbit remains partially protected inside this magnetic cocoon. The Moon sits mostly outside it. Mars sits almost entirely beyond it. During the long journey between planets, astronauts would travel through deep space exposed to constant cosmic radiation. Tiny high-energy particles moving near the speed of light would pass through spacecraft walls and human tissue alike. Some originate from distant supernova explosions. Others erupt from violent solar storms. Over time, this radiation damages DNA. It increases cancer risk. It may affect the nervous system and cognitive function. Scientists still do not fully understand the long-term neurological consequences of deep space radiation exposure because humans have never remained outside Earth's protective magnetic shield for such prolonged periods. The Apollo astronauts traveled beyond the magnetosphere briefly during their lunar missions, but those journeys lasted only days. A Mars mission would last years. Engineers can add shielding, but shielding itself creates another brutal trade-off. More shielding means more mass. More mass means more fuel. More fuel means larger launch systems and harsher rocket equation penalties. Every solution creates another problem. Water tanks may provide partial radiation protection because water absorbs some radiation. Some mission concepts place sleeping quarters behind water storage walls for added shielding. Others explore underground habitats on Mars using natural rock as protection. But during the journey itself, astronauts remain vulnerable inside relatively thin spacecraft structures drifting through interplanetary darkness. Solar storms are especially frightening. A sufficiently powerful solar particle event could expose astronauts to dangerous radiation doses within hours. Crews would likely need small, heavily shielded storm shelters inside the spacecraft where they could hide temporarily during major solar eruptions. Imagine hearing an alarm deep inside a spacecraft millions of kilometers from Earth. The Sun has erupted. Radiation levels are rising. The crew retreats into a cramped shelter surrounded by supplies and water tanks, while invisible particles stream through space around them. Outside the protective cocoon of Earth, even sunlight becomes something dangerous. Sleep itself may also become difficult during such a mission. Human circadian rhythms evolved beneath Earth's 24-hour cycle. Mars has a day surprisingly close to Earth's at around 24 hours and 37 minutes. But the long, deep space transits exist outside any natural planetary rhythm. Artificial lighting becomes the only sunrise and sunset astronauts experience for months at a time. Isolation compounds the strain. Psychological fatigue grows slowly in confined environments where privacy barely exists. Every crew member sees the same walls, the same faces, the same machinery humming endlessly around them. Tiny interpersonal tensions can grow dangerously large over time when there is nowhere else to go. Antarctica simulations and underwater habitat studies attempt to model these effects, but none perfectly replicate the reality of being unable to return home. Because on Mars, distance itself becomes part of the psychological burden. Earth is always impossibly far away, and perhaps that is the strangest part of all. Humanity often imagines Mars as a triumph of exploration, a symbol of progress. Yet the deeper one studies the mission, the more it resembles endurance. Survival against physics, against time, against isolation, against the limits of the human body itself. Mars does not merely challenge our technology. It challenges the fragile biology that evolved beneath Earth's protective skies. For all the terrifying engineering problems surrounding Mars, there is one detail that quietly frightens mission planners more than almost anything else. The launch from Mars must work perfectly the very first time. On Earth, rockets fail more often than most people realize. Even after decades of spaceflight experience, launches still suffer engine malfunctions, software errors, fuel leaks, structural failures, and unexpected shutdowns. Engineers reduce the risks through endless testing and redundancy, but rockets remain incredibly delicate machines balanced on the edge of controlled explosion. The difference is that on Earth, failure usually happens near factories, launch pads, engineers, spare parts, and entire industrial networks capable of trying again. Mars offers none of that. A return rocket sitting on the Martian surface may represent the only path home for an entire crew. If it fails during ascent, there is no backup vehicle hidden nearby. No rescue team waiting over the horizon. No possibility of manufacturing another rocket from local materials within weeks or months. Failure becomes permanent with terrifying speed. This is why the Mars Ascent Vehicle is considered one of the single most difficult spacecraft ever proposed. Unlike rockets launched from Earth, it must survive an extraordinary chain of events before ever igniting its engines. First, it must be built on Earth and launched successfully into space. Then it must survive months traveling through deep space exposed to radiation, temperature swings, and constant vibration. After arriving at Mars, it must descend safely through the atmosphere and land without damage. Then it may sit dormant for over a year waiting for the return window while enduring dust storms, freezing nights, and relentless environmental stress. Only after all of that must it finally awaken and function flawlessly on the first launch attempt in human history from another planet. Engineers lose sleep thinking about this problem because every stage introduces new ways for failure to quietly accumulate. A small crack developing during landing, dust contaminating a fuel line, electronics degrading slowly in the cold. Tiny problems that might be reparable on Earth become potentially fatal on Mars. And unlike robotic missions, a human return vehicle cannot simply partially succeed, cannot limp through the mission. It either launches correctly or astronauts remain trapped. Even fueling the rocket creates extraordinary complications. Traditional rockets are often fueled shortly before launch because many propellants are cryogenic. They must remain extremely cold to stay liquid, Liquid oxygen boils at around -183 degrees Celsius. Liquid methane also requires deep cryogenic temperatures. Maintaining these fluids for months or years on Mars is enormously difficult. Tanks need insulation. Refrigeration systems require power continuously. Any leak or system degradation could slowly reduce fuel reserves over time. Mission planners therefore face a constant balancing act between simplicity, reliability, and mass. Some designs attempt to minimize long-term fuel storage by manufacturing propellant gradually on Mars through ISRU systems. Others explore more stable fuel combinations with lower performance. Every option carries trade-offs. Higher performance engines reduce fuel mass but increase complexity. Simpler fuels improve reliability but demand heavier spacecraft. There are no perfect solutions, only compromises against physics. The Martian environment itself also complicates launch in subtle ways. Mars has lower gravity than Earth, which helps rockets lift off. But the atmosphere creates strange aerodynamic conditions unlike anything experienced on Earth. It is thick enough to produce drag and dust interactions, yet too thin for normal aerodynamic control surfaces to work effectively. During ascent, engines and guidance systems must operate in this unusual regime where the air behaves differently from both Earth and vacuum. Even parachutes become far less useful because the atmosphere is so thin. This is why landing large payloads on Mars remains one of NASA's greatest engineering nightmares. The famous phrase 7 minutes of terror describes the landing sequence because spacecraft entering the atmosphere must survive hypersonic heating, deploy parachutes in thin air, ignite descent rockets, and land autonomously with almost no real-time intervention from Earth. A future human mission would involve payloads vastly heavier than any rover ever landed before. And everything needed for the return journey must survive that descent intact. Then there is dust. Martian dust infiltrates everything. It clings electrostatically to surfaces. It scratches seals and joints. During the Apollo missions, astronauts found lunar dust so abrasive it damaged suit materials and irritated lungs after only brief exposure. Martian dust may prove even more dangerous because it contains perchlorates, chemically reactive compounds potentially harmful to humans and machinery alike. Fine dust particles could interfere with moving components inside the ascent vehicle over long surface stays. Engineers must design systems capable of enduring contamination for years without maintenance infrastructure. The return rocket also faces another silent enemy: temperature cycling. Mars experiences dramatic swings between day and night temperatures. Equipment repeatedly expands and contracts as it heats and cools. Over time, this process can weaken materials and seals. Electronics become especially vulnerable because repeated thermal stress slowly damages delicate connections. On Earth, such systems can be monitored continuously and replaced when needed. On Mars, astronauts may only have limited spare components and repair capability. Every system must therefore be extraordinarily robust while also remaining lightweight enough to transport across interplanetary space. This contradiction sits at the heart of Mars engineering. Reliability usually requires heavier systems, more redundancy, and stronger materials. But every additional kilogram worsens the fuel problem. Every improvement demands another sacrifice elsewhere. And beyond all the engineering details lies something deeply human. Imagine the emotional weight carried by astronauts preparing for launch from Mars. Outside the habitat stands the only machine capable of carrying them back to Earth. They know every calculation behind it, every risk, every compromise engineers made years earlier on another world. Then finally the launch window arrives. The planets align. The countdown begins. Engines ignite beneath the red dust. And for the first time in human history, people attempt to rise from another planet knowing that if this moment fails, the silence afterward may last forever. And yet, despite every danger we have explored tonight, many scientists and engineers still believe humanity will eventually attempt this journey. That belief may seem strange after everything we now understand about Mars. The crushing fuel requirements, the years of isolation, the radiation exposure, the brutal mathematics of orbital mechanics, the terrifying dependence on a single launch from another planet. But throughout history, human beings have repeatedly crossed boundaries that once appeared impossible. Oceans once seemed endless and fatal. Polar regions once appeared unreachable. Even powered flight was considered fantasy until suddenly it existed. Mars now sits in that same strange territory between impossibility and inevitability. The reason is not only scientific curiosity. It is something deeper inside human nature. Humanity has always looked toward distant horizons and imagined crossing them. Mars simply happens to be the next horizon waiting in the dark. In some ways, the challenge of returning from Mars reveals something profound about civilization itself. Modern life often creates the illusion that technology can solve anything quickly. We are surrounded by instant communication, rapid transportation, and constant convenience. But Mars strips all of that away. It reminds us that physics still rules the universe. Distance still matters. Gravity still demands payment. The laws governing planets and motion existed billions of years before humans appeared, and they remain completely indifferent to ambition. Mars does not care about optimism. It does not care about politics or national pride or technological excitement. It only responds to energy, mass, velocity, and timing. There is something strangely humbling about that realization. Perhaps this is why Mars captures the imagination so powerfully. It forces humanity to confront the scale of the cosmos honestly. On Earth, people can almost forget they live on a planet moving through space. Gravity feels permanent and invisible. Air feels endless. Distance feels manageable. But Mars exposes how fragile those assumptions really are. A few millimeters of spacecraft metal become the only barrier between life and vacuum. A delayed launch window becomes the difference between survival and entrapment. A small fuel calculation becomes a matter of whether human beings ever see Earth again. Suddenly, the universe feels enormous and ancient once more. Even the sky on Mars would constantly remind astronauts of this reality. During the daytime, the sun appears smaller than it does on Earth because Mars sits farther away. Sunlight feels dimmer and colder. The sky itself takes on a butterscotch color due to fine dust suspended in the atmosphere. At sunset, the colors reverse from Earth's familiar pattern. Martian sunsets glow blue near the sun while the surrounding sky darkens red. Imagine standing there after months on another world watching that strange twilight spread across silent deserts older than human civilization itself. Somewhere above that alien horizon hangs Earth. Tiny, distant, fragile. Every astronaut who has viewed Earth from space has described a powerful emotional reaction. The planet suddenly appears small and delicate against the blackness. National borders vanish. Conflicts seem absurd. Humanity becomes visibly united as a single species living on a thin layer of atmosphere wrapped around stone and ocean. A Mars crew would experience that feeling more intensely than anyone in history because Earth would no longer dominate the sky. It would become only another bright object among countless stars. Home reduced to a pale point of light. And perhaps that perspective alone explains why humanity keeps dreaming about Mars despite the danger. Not because Mars itself is beautiful or welcoming. It is not. Mars is cold, dry, toxic, and unforgiving. But standing there would fundamentally change how humans understand their place in the universe. The first people to return successfully from Mars would carry more than scientific samples. They would carry a psychological transformation impossible to fully predict. They would have lived farther from Earth than any humans before them. They would have survived under skies no human eyes evolved to see. And after years in deep space and alien landscapes, they would finally watch Earth grow larger again through spacecraft windows during the long journey home. Imagine that moment. After months drifting through darkness, Earth slowly brightens ahead. Oceans become visible. White clouds swirl across blue continents. Gravity waits below like an old forgotten sensation returning at last. The crew enters the atmosphere surrounded by fire as the capsule slams into denser air at enormous speed. Then parachutes open above a world they have not touched in years. The smell of Earth's atmosphere returns for the first time. Wind, moisture, plants, rain. Simple things that may feel almost miraculous after surviving the sterile machinery and dust of Mars. Yet even if humanity succeeds, the deeper truth remains unchanged. Mars will never become easy. No clever engineering trick removes the immense distances between planets. No future technology fully erases the dangers of isolation, radiation, and gravity. We may reduce the risks. We may improve reliability. We may eventually build permanent habitats beneath the Martian soil. But Mars will always demand respect because the challenge is woven into the architecture of the solar system itself. Perhaps that is why the story of Mars feels so strangely beautiful. It is not a story about conquering nature. It is a story about learning how small humanity truly is against the scale of cosmic forces, and still deciding to try anyway. Tonight, as Earth turns quietly beneath your window and the familiar pull of gravity holds everything gently in place, Mars continues circling the sun in silence far beyond the darkness overhead, waiting patiently, cold and distant, a world that may someday welcome human footsteps, but only after demanding one of the greatest prices exploration has ever required. If there is one lesson repeated again and again throughout the history of space exploration, it is this: the universe is rarely impressed by human confidence. Again and again, engineers have approached space missions believing they understood every danger, only for reality to reveal some entirely new problem hidden beneath the surface. And Mars may contain more hidden problems than any destination humanity has ever attempted to reach. Because even after solving propulsion, timing, radiation, isolation, and survival, there remains another uncertainty lingering quietly beneath every discussion of a human Mars return. Nobody truly knows how human psychology will react to being so far from Earth for so long. This may sound less dramatic than rockets or gravity wells, but many experts consider it one of the greatest unknowns of the entire mission. Human beings evolved in tribes, landscapes, weather, sunlight, oceans, forests, and open skies. For hundreds of thousands of years, our nervous systems developed inside living ecosystems filled with natural sounds and constant sensory variation. A Mars mission removes almost all of that. The crew would spend years inside carefully engineered environments dominated by machinery, recycled air, artificial lighting, and confined spaces. Every wall would be functional, every object calculated for mass efficiency. Even privacy would become limited because spacecraft and habitats must remain compact to reduce launch weight. There would be no forests, no rainstorms against windows, no cities, no crowds, no possibility of stepping outside safely without layers of protective equipment separating human skin from the environment. In many ways, astronauts on Mars may experience a kind of sensory exile from Earth itself. We already know isolation affects the human mind in strange ways. Researchers studying crews in Antarctic stations, submarines, and underwater habitats have documented mood changes, sleep disruption, emotional fatigue, social tension, and cognitive decline during long periods of confinement. Sometimes small disagreements slowly intensify because people cannot physically separate from one another. Habits that once seemed harmless become deeply irritating after months of repetition. Tiny sounds become impossible to ignore. Silence itself can begin feeling oppressive. Now imagine those same pressures combined with the knowledge that outside the habitat lies an environment instantly fatal to human life. Mars astronauts would never truly relax the way people relax on Earth. Every breath inside the habitat would depend on machinery functioning correctly. Every excursion outside would require complex preparation and constant awareness of danger. Even something as simple as a damaged glove or air leak during a surface walk could become life-threatening within minutes. Over time, that constant low-level stress may weigh heavily on the human nervous system. And there is another deeply unsettling factor. Distance changes emotional reality. Here on Earth, people often take connection for granted because communication feels immediate. A message arrives instantly. A phone call crosses continents in seconds. But Mars would restore emotional distance in a way humanity has not experienced for centuries. Families could not truly converse naturally with astronauts because every exchange would be interrupted by communication delays. Imagine receiving news from Earth about illness, death, or personal tragedy, then being unable to respond in real time. Imagine hearing the voice of someone you love with 20 minutes of silence separating every sentence. The emotional texture of human relationships would fundamentally change under those conditions. Some psychologists worry this may create feelings of detachment or unreality over time. Earth itself could begin feeling psychologically distant rather than merely physically far away. Astronauts may slowly feel caught between two worlds, no longer fully connected to Earth, yet never truly belonging to Mars either. Sleep may become another hidden struggle. On Earth, human biology synchronizes naturally with sunlight, weather, temperature cycles, and social rhythms. Spacecraft environments disrupt many of these cues. Astronauts aboard the International Space Station already experience sleeping difficulties because they witness multiple sunrises and sunsets each day while orbiting Earth. Mars missions would involve long transit periods without any natural planetary cycle visible outside. Artificial lighting systems would attempt to regulate circadian rhythms, but biology does not always adapt perfectly to engineered conditions. Chronic sleep disruption can gradually impair judgment, mood, and cognitive performance. Over years, even subtle psychological effects could become mission-threatening. Then there is monotony. Human beings crave novelty more than many people realize. Earth constantly provides changing scenery, seasons, weather, conversations, sounds, and spontaneous experiences. Mars may become psychologically repetitive in ways difficult to fully simulate beforehand. Day after day, astronauts may see the same dusty landscapes beneath the same muted sky, the same equipment checks, the same routines, the same confined interiors glowing with artificial light. During the Apollo missions, astronauts remained on the Moon only briefly, yet several described the environment as eerily lifeless. Mars missions would extend that exposure across years. Some researchers believe the sheer absence of life on Mars may affect human psychology more deeply than expected. No trees moving in wind, no birds, no insects, no oceans, no biological sounds at all. Only dust, stone, machinery, and silence. Yet perhaps the strangest possibility is that some astronauts may not want to leave Mars emotionally once they adapt. Human beings are remarkably flexible creatures. People normalize extraordinary environments over time. The habitat may eventually feel familiar, the routines stable. Earth itself may begin seeming distant and abstract after years away. Returning home could become psychologically disorienting in ways nobody fully anticipates, because by then, the astronauts who left Earth years earlier may no longer entirely exist. Mars would change them, quietly, slowly, inevitably, and perhaps that is the final hidden truth about returning from Mars. The greatest challenge may not simply be bringing human bodies home across millions of kilometers of space. It may be bringing human minds home as well. Perhaps the most haunting part of the Mars return problem is that the universe never intended creatures like us to perform journeys like this. Human beings evolved beneath thick atmosphere, stable gravity, abundant water, and magnetic protection from cosmic radiation. Every aspect of our biology assumes Earth. Our lungs assume atmospheric pressure. Our muscles assume gravity. Our minds assume open environments filled with life and natural rhythms. Mars strips away all of those assumptions one by one until only the raw mechanics of survival remain. In that sense, a human Mars mission is not simply exploration. It is a negotiation with the boundaries of human evolution itself. And yet, strangely, this may also be why Mars fascinates us so deeply. Because somewhere inside the challenge lies a question humanity has always asked. How far from home can we go before we stop being who we were? Imagine the first astronauts finally preparing to depart Mars after more than a year on the surface. By then, the routines of another planet may feel oddly familiar. The crew has likely memorized the surrounding landscape. The patterns of dust on nearby rocks, the timing of communications with Earth, the strange pale sunlight drifting through habitat windows each morning. Mars may no longer feel entirely alien. Humans adapt quickly even to impossible circumstances. perhaps that adaptation itself becomes unsettling. Because after enough time, Earth may begin feeling like the distant world instead. Memory softens with distance, familiar streets, rainfall, forests moving in wind, the smell of oceans. These experiences could slowly begin feeling unreal compared to the immediate reality of survival on Mars. Then finally the launch window arrives. The return rocket stands ready beneath the cold Martian sky. Fuel manufactured slowly over many months waits inside insulated tanks. Systems are checked again and again because no failure can be tolerated now. The astronauts climb aboard carrying samples, equipment, and perhaps a strange, quiet understanding that history has narrowed down to this single moment. Then ignition. Engines erupt beneath the spacecraft. Dust expands outward across the surface. Gravity loosens its grip. For the first time in human history, people rise upward from another planet carrying the hope of returning home across interplanetary space. The ascent itself may feel violent after months in lower gravity. Vibrations shaking through the cabin. Acceleration pressing bodies into seats. Outside the windows, the Martian landscape rapidly shrinks away beneath swirling clouds of dust and thin atmosphere. Soon Mars itself begins transforming from a world into a sphere suspended in blackness. Another planet hanging silently beside countless stars. And then comes the long journey home. Months once again spent drifting through deep space. Months of confinement, maintenance, exercise, caution, and waiting. The crew may watch Mars slowly fade behind them while Earth brightens almost imperceptibly ahead. Every day brings them closer to home, yet the distance still remains almost unimaginable by human standards. Millions of kilometers of emptiness separate them from the oceans and skies where they were born. During this return journey, the astronauts may experience something difficult to describe. They have now lived beyond Earth longer than any humans before them. They have walked beneath another sky, survived another planet, seen Earth reduced to a distant star. In psychological terms, they may no longer fully belong to ordinary human experience. Throughout history, explorers returning from distant frontiers often described feeling detached from the societies they came home to. Sailors crossing oceans for years sometimes struggled to reconnect with normal life afterward. Polar explorers returned carrying memories difficult to communicate to people who had never seen such places. A Mars crew may experience this separation more intensely than any explorers in history because their journey would transcend not merely geography, but worlds themselves. Eventually, Earth begins dominating the windows again. Blue oceans growing brighter. White clouds swirling across continents. After years of sterile spacecraft air and Martian dust, even the sight of weather systems may appear overwhelmingly beautiful. The crew prepares for re-entry. One final critical maneuver. One last confrontation with physics. The spacecraft plunges into Earth's atmosphere, traveling at enormous speed. Heat builds outside the capsule until plasma surrounds the vehicle in burning light. For several minutes, communication may vanish entirely as ionized air blocks radio signals. Inside, astronauts wait in darkness and vibration while gravity slowly returns after years of reduced weight. Then finally parachutes deploy. The violent motion eases. Earth's atmosphere surrounds them once more. Wind touches the capsule. Moisture fills the air outside. Somewhere below lies an entire living world. Trees, oceans, billions of people. birds crossing skies the astronauts have not seen in years. And perhaps in that moment, the emotional weight of the journey finally arrives all at once. Because surviving Mars would not simply prove human engineering capability. It would prove something much older and deeper about our species. Human beings are fragile creatures. Soft biological organisms evolved on a small planet orbiting an ordinary star. And yet somehow those same fragile creatures learned to calculate the movement of worlds, build machines capable of crossing space, and return safely from another planet millions of kilometers away. There is something almost unbelievable about that fact. But perhaps the universe has always worked this way. Tiny conscious beings emerging briefly from matter and gravity, looking upward at impossible distances, then deciding to cross them anyway despite fear, danger, and overwhelming odds. Mars may never become easy. It may never become safe in the way Earth feels safe. But maybe that is not the point. Maybe the point is that somewhere in the silence between planets, humanity discovers what it truly is. Not masters of the cosmos, not conquerors of worlds, only travelers, temporary wanderers moving carefully through an ancient and indifferent universe, while carrying the memory of home inside fragile spacecraft drifting through the dark. Long before any human being ever looked through a telescope at Mars, the red planet already carried a strange emotional power in the human imagination. Ancient civilizations saw its reddish glow wandering across the night sky and associated it with war, fire, blood, and gods of conflict. Even without understanding planets scientifically, people sensed something different about that distant crimson light. It moved strangely compared to the fixed stars. Sometimes it brightened dramatically. Sometimes it faded into darkness. It behaved less like a peaceful celestial object and more like something restless wandering through the heavens. Thousands of years later, humanity finally understands what Mars truly is. Not a god, not a supernatural force, only a cold desert planet orbiting farther from the sun than Earth. And yet somehow the mystery remains, because the more we learn about Mars, the more extraordinary it becomes that human beings even contemplate traveling there and returning alive. The distances alone are difficult for the human mind to truly absorb. Light itself, moving at nearly 300,000 kilometers every second, still requires minutes to cross the gap between Earth and Mars. Human spacecraft using current propulsion technology require many months. During those months, astronauts would exist in an environment no organism on Earth naturally evolved to survive. Tiny streams of radiation pass continuously through their spacecraft. Outside lies vacuum colder and emptier than anything experienced on Earth. Ahead waits a world that can kill unprotected humans within moments. And still the dream continues. Perhaps because Mars represents something larger than exploration. It represents humanity confronting the scale of the universe directly. On Earth, modern civilization creates the comforting illusion that human beings dominate their environment. Cities glow at night. Airplanes cross oceans effortlessly. Information circles the planet instantly. But Mars strips away that illusion completely. There, survival depends not on comfort or convenience, but on obeying physical laws with absolute precision. A single calculation error can become fatal. A mechanical failure can become irreversible. Gravity itself becomes an enemy requiring enormous energy to overcome. In this way, Mars reminds humanity that despite all our technology, we remain biological creatures existing inside a universe governed by forces far older and more powerful than ourselves. There is something strangely calming about this realization. The universe does not hate humanity. It is simply indifferent. Mars is not hostile in an emotional sense. It does not wish suffering upon astronauts. It merely exists according to the same physical principles governing stars, planets, and galaxies everywhere. The same gravity keeping oceans on Earth also traps spacecraft on Mars. The same orbital mechanics carrying Earth around the Sun also dictate when return journeys become possible. Everything follows patterns written into reality itself. Human beings must adapt to those patterns rather than expecting the universe to adapt to us. And perhaps this is why stories about Mars feel almost philosophical as much as scientific. They force us to ask uncomfortable questions about what exploration truly means. Is exploration about conquering places? Or is it about accepting vulnerability while moving into the unknown anyway? The language humans often use about space can sound militaristic. Conquering planets, colonizing worlds, dominating space. But Mars quietly resists that language. Because every aspect of a Mars mission reveals how dependent humans remain on fragile systems and careful preparation. Astronauts would not dominate Mars. They would survive there cautiously inside small protected environments while the planet itself remained immense, ancient, and fundamentally indifferent around them. In many ways, Mars resembles the deep ocean more than new land. Human beings may visit it, study it, build temporary shelters upon it. But the environment itself remains fundamentally incompatible with unprotected human life. This reality may shape the future of space exploration in profound ways. Perhaps humanity's destiny among the planets will not resemble old fantasies of effortless galactic empires spreading endlessly through the stars. Perhaps it will look slower, quieter, and more fragile. Small groups of travelers moving carefully between hostile worlds while carrying miniature islands of Earth with them wherever they go. Tiny habitats filled with air, water, warmth, memory, and human voices drifting through enormous cosmic darkness. And maybe that image is more beautiful precisely because it acknowledges human fragility honestly. The astronauts who someday stand on Mars may experience emotions difficult for us to imagine now. Fear certainly, almost certainly, but perhaps also a strange intimacy with the universe itself. On Earth, people are surrounded constantly by signs of humanity. Roads, buildings, lights, noise. Civilization creates a layer separating daily life from awareness of the cosmos. Mars would remove that layer entirely. Every glance outside a habitat window would reveal another planet stretching silent beneath alien skies. Every sunrise would occur in a place where no human ancestors ever walked. Every breath would depend on technology consciously resisting the natural environment. In such a place, the reality of existence inside a vast universe may feel impossible to ignore. And perhaps someday, after all the engineering challenges are finally solved, after rockets rise successfully from the Martian surface and human crews complete the long return home, the greatest legacy of Mars exploration may not be scientific discoveries or technological advances at all. It may be perspective, a deeper understanding of how rare and precious Earth truly is. Because astronauts who survive Mars may return carrying an awareness few humans have ever fully experienced. The knowledge that out there beyond our atmosphere lies an endless darkness filled mostly with cold worlds, radiation, silence, and distance. And somewhere within all that darkness exists one small blue planet covered in oceans, forests, clouds, music, weather, and life. A planet fragile enough that human beings can leave it only with extraordinary difficulty, yet beautiful enough that after crossing millions of kilometers of empty space, the greatest desire any traveler may still feel is simply to come home again. And maybe that is the quiet truth hidden underneath every conversation about Mars. The journey is not really about escaping Earth. It is about finally understanding Earth for the first time. Human beings evolved beneath blue skies so familiar that most people rarely stop to notice them anymore. Gravity feels ordinary because it has surrounded us since birth. Air feels infinite because lungs draw breath automatically thousands of times each day without conscious thought. Even sunlight appears simple and constant. But from Mars, all those ordinary things would suddenly seem extraordinary. Astronauts living on another planet would likely become intensely aware of how delicately balanced Earth truly is. Because the farther humanity travels into space, the more obvious it becomes that Earth is not the default state of the universe. Earth is the exception. Most of the cosmos is not filled with forests, oceans, breathable air, and living ecosystems. Most of the cosmos is silent vacuum and hostile worlds orbiting distant stars. In a strange way, the difficulty of returning from Mars teaches this lesson more clearly than almost anything else in science. The sheer amount of energy required simply to leave another planet and come home reveals how deeply connected humans remain to Earth's environment. We are not naturally cosmic creatures. Every step beyond our atmosphere requires enormous effort because evolution shaped us for one world only. And yet, despite this limitation, human beings continue reaching outward. There is something profoundly moving about that contradiction. Fragile organisms made from water and carbon somehow developed curiosity powerful enough to challenge gravity itself. Perhaps future generations will look back on the first Mars missions the way modern people view ancient ocean voyages. Dangerous, primitive, heroic. The first crews may travel inside cramped spacecraft vulnerable to radiation and mechanical failure in ways future civilizations eventually overcome. Someday, advanced propulsion systems may shorten travel times dramatically. Artificial gravity habitats may protect astronaut health. Sophisticated life support systems may recycle resources with near-perfect efficiency. Mars bases may expand gradually beneath protective domes or underground caverns shielded from radiation and dust storms. But even if all of that happens, one reality will remain unchanged. Space itself will always be vast beyond normal human intuition. The solar system is enormous. The nearest star beyond the Sun lies more than 4 light-years away. Mars already pushes humanity to the edge of what current civilization can realistically attempt. And perhaps that scale is important, because it forces humility. Modern life often encourages the illusion that progress moves infinitely upward. Faster technology, larger cities, greater control. But the universe quietly reminds us that some boundaries are not easily crossed. Physics demands patience. Gravity demands energy. Distance demands time. There are no shortcuts through these realities. Mars becomes difficult not because engineers lack intelligence, but because the cosmos itself is immense beyond human convenience. Still, humanity keeps preparing. Space agencies continue studying habitats, propulsion systems, radiation shielding, food production, psychology, and orbital mechanics. Engineers refine designs for reusable rockets. Scientists test methods for producing oxygen and fuel from Martian resources. Every year, the dream inches slightly closer to reality. And perhaps somewhere alive today is a child who will someday walk across the Martian surface for real. A person who will look upward beneath a dusty red sky and see Earth shining faintly in the darkness. Imagine what that moment might feel like emotionally. To stand on another planet while knowing every human story, every ocean, every city, every language, every memory of childhood exists on that tiny distant point of light hanging overhead. Perhaps that awareness changes people permanently because it compresses the entire human experience into something small enough to hold within a single glance. Astronauts often describe Earth from orbit as borderless and fragile. Mars explorers may experience an even deeper version of that revelation. Because from Mars, Earth is not merely a country or civilization. It is home in the most absolute sense imaginable. The only naturally living world any human being has ever known. And maybe that is why the idea of returning matters so much emotionally. Going to Mars captures imagination because it represents courage and discovery. But coming home represents something older and more human. It represents attachment, memory, belonging, the desire to survive impossible journeys and still find one's way back again. Throughout history, stories about exploration have often ended this way. Travelers crossing deserts, oceans, mountains, and polar ice rarely dreamed only of departure. Deep beneath the excitement of discovery remained another hope waiting quietly in the background. The hope of eventually seeing home again after surviving the unknown. Mars simply transforms that ancient human story onto a cosmic scale. A journey not across oceans, but between planets. And as Earth turns quietly tonight beneath clouds and city lights, Mars continues moving through the darkness millions of kilometers away. Cold winds still shape its deserts. Dust storms still sweep across empty plains where no human voice has ever echoed. The launch windows still open and close according to orbital mechanics older than life itself. Somewhere in the future, human beings may finally cross that distance and return safely. But even then, Mars will remain what it has always been. A reminder that the universe is beautiful, ancient, indifferent, and unimaginably vast. And perhaps also a reminder that despite all of humanity's technology and ambition, the most precious destination any traveler may ever know is still the small blue world where the journey first began. Maybe one day, centuries from now, human beings will look back at the first Mars missions with the same distant fascination we now feel toward wooden ships crossing unknown oceans. Future civilizations may consider our rockets primitive and fragile. They may laugh gently at how slowly humans once traveled between worlds. 7 months drifting through space may someday seem unbearably inefficient to descendants living with technologies we cannot yet imagine. But perhaps they will also recognize something admirable about these early journeys. Because the first people who attempt to leave Mars and return home will do so without certainty, without guarantees. They will travel knowing that physics itself stands against them at every stage. And still they will go. There is something ancient about that impulse. Humanity has always moved toward difficult horizons despite danger. The first people who crossed frozen land bridges into unknown continents could not know what waited ahead. The first sailors who disappeared beyond the edge of familiar coastlines had no satellite navigation, no weather forecasts, no rescue systems. Yet curiosity kept pulling human beings farther outward generation after generation. Mars may simply be the newest expression of that same instinct written now on an interplanetary scale. And perhaps this instinct emerges from something fundamental about consciousness itself. Human beings do not merely survive within the universe. We wonder about it. We imagine distant places long before we can reach them. We stare upward into darkness and ask impossible questions. Mars has occupied that space in the human imagination for thousands of years because it sits close enough to see, yet far enough to remain mysterious. A visible world hanging just beyond reach. Even now, telescopes on Earth can watch dust storms spread across the Martian surface. Orbiters can map ancient river valleys carved billions of years ago when liquid water once flowed there. Rovers crawl slowly across silent deserts searching for traces of ancient habitability. All these machines whisper the same strange possibility. Mars was once different. Long ago it may have possessed lakes, rivers, thicker atmosphere, and perhaps environments capable of supporting primitive life. But something changed. Mars lost much of its atmosphere over immense spans of time. This magnetic field faded. Solar radiation slowly stripped away lighter gases into space. Water disappeared from the surface or froze underground. The planet became cold and barren. In some ways, Mars may represent a warning written across an entire world. A reminder that planets themselves are not permanent, stable things. They evolve, change. Sometimes they die slowly beneath cosmic forces beyond their control. Perhaps that is another reason Mars unsettles people emotionally. It looks strangely familiar while simultaneously feeling profoundly lifeless. Dry riverbeds suggest ancient water. Sedimentary rocks hint at vanished environments. The planet feels haunted by the memory of habitability itself. Astronauts standing there may experience an eerie awareness that they are walking through the ruins of a world that once looked more alive than it does now. And somewhere inside that realization may emerge another uncomfortable thought. Earth too exists within cosmic time. Our atmosphere, oceans, magnetic field, and ecosystems are not guaranteed forever. The universe changes continuously whether humanity notices or not. Maybe this is why the idea of returning from Mars feels emotionally powerful beyond its engineering difficulty. It symbolizes more than survival. It symbolizes reconnection with the fragile conditions that allow human life to exist at all. The farther astronauts travel from Earth, the more miraculous ordinary Earth becomes. A blue sky stops feeling ordinary. So does rain, wind moving through trees, ocean waves. Even simple gravity pressing gently against the body may someday feel comforting after years in reduced gravity environments. Perhaps the greatest irony of Mars exploration is that traveling to another planet may deepen humanity's appreciation for the one we already have. And maybe that emotional transformation matters as much as any scientific discovery. Because civilizations often forget the rarity of what surrounds them every day. People become accustomed to breathable air and stable climates because those things feel permanent during individual human lifetimes. Mars reminds us they are not universal at all. Most worlds in the cosmos are hostile to life. Most of space is silence and radiation stretching across unimaginable distances. Earth is extraordinary precisely because it feels ordinary to the beings who evolved upon it. Tonight, somewhere beneath Earth's atmosphere, millions of people are sleeping peacefully without thinking about oxygen systems, radiation shielding, launch windows, or escape velocities. Gravity holds everything gently in place. Oceans continue moving beneath the moon. Clouds drift above cities glowing softly in the dark. And beyond all of it, Mars circles silently through the cold blackness between worlds, waiting, unchanged by human dreams or fears. The mathematics governing its orbit will continue long after every civilization now alive has vanished. Yet perhaps sometime within the coming centuries, small groups of humans really will stand there looking back toward Earth. Tiny figures wrapped in protective suits beneath a pale salmon-colored sky. They may feel fear, wonder, loneliness, pride, but perhaps above all they will feel distance in a way no human beings before them ever truly have. And then eventually, if everything works correctly, if the engines ignite and the calculations hold and the fragile systems survive, they will begin the long return home across interplanetary darkness. A journey shaped entirely by gravity, fuel, time, and the silent laws of the cosmos. Because in the end, that is the true answer to why returning from Mars is so hard. Not because humanity lacks intelligence or courage, but because the universe itself is vast beyond comprehension. And every successful journey between worlds requires human beings to momentarily align themselves with the immense and ancient mechanics of reality itself. And perhaps somewhere far in the future, after humanity has crossed the distance to Mars many times, people may forget how terrifying these first journeys once seemed. Future children born beneath artificial domes on another world may grow up hearing stories about the early missions the same way modern people hear stories about ancient explorers crossing stormy seas in wooden ships. They may struggle to imagine how fragile the first Mars expeditions truly were, how every launch window mattered, how every kilogram of fuel had to be calculated with obsessive precision, how astronauts traveled knowing there might be no rescue if something failed millions of kilometers from home. But for the first cruise, the danger will feel very real, because no amount of preparation can completely remove uncertainty from something humanity has never attempted before. Every Mars mission will carry invisible questions waiting quietly in the background. Questions engineers cannot fully answer until human beings actually go there and return. How will the body respond after years away from Earth gravity? How will the mind adapt to such immense isolation? How will machinery survive prolonged exposure to Martian dust and radiation? What unforeseen failures will emerge only after the mission begins? Space exploration has always revealed surprises, sometimes beautiful ones, sometimes dangerous ones. During Apollo missions, astronauts discovered lunar dust behaved in ways nobody predicted. During long space station missions, researchers learned the human body changes more dramatically in microgravity than expected. Mars almost certainly holds its own unknowns waiting patiently beneath the surface of current mission plans. And yet humanity continues preparing because curiosity remains stronger than fear surprisingly often. There is something deeply characteristic about our species in that fact. Human beings repeatedly move toward uncertainty not because safety is guaranteed, but because understanding matters enough to justify risk. Mars may represent the purest expression of that instinct ever attempted. A mission so difficult that even discussing it forces humanity to confront uncomfortable truths about fragility, mortality, distance, and dependence on technology. But perhaps there is also hope hidden inside the challenge itself. Because every problem Mars presents has inspired extraordinary creativity from scientists and engineers across generations. The need for efficient propulsion drives research into advanced engines. The need for survival encourages breakthroughs in recycling systems, robotics, medicine, and sustainable habitats. The challenge of Mars forces civilization to think carefully about resilience, about how humans survive in hostile environments with limited resources. In strange ways, technologies developed for Mars may eventually help life on Earth as well. Closed-loop water recycling, efficient agriculture in harsh conditions, renewable energy systems, autonomous medical support. Throughout history, space exploration has repeatedly generated unexpected benefits far beyond the missions themselves. Perhaps Mars will continue that tradition. But even if humanity someday establishes permanent settlements there, the emotional relationship between Earth and Mars may remain complex forever. Earth will always possess something Mars cannot easily replicate: deep oceans, dense atmosphere, open ecosystems, billions of years of uninterrupted biological evolution shaping every landscape. Mars may eventually host cities beneath protective domes glowing softly against the cold desert night. Yet those cities would still exist as carefully maintained islands of habitability surrounded by a world fundamentally indifferent to human life. Earth, on the other hand, supports life naturally and effortlessly. Trees grow without machines maintaining pressure systems. Rain falls freely from the sky. Rivers flow without pumps. Birds cross continents without spacesuits. The farther humanity travels into space, the more miraculous those ordinary Earth processes may begin to appear. Perhaps astronauts returning from Mars will experience this more strongly than anyone before them. Imagine stepping outside after years away and feeling wind directly against skin without protective layers. Hearing insects at night, smelling plants after rain. Watching clouds drift overhead while gravity presses comfortably against the body once again. Things that once felt ordinary may suddenly feel astonishingly precious. Maybe that becomes the final hidden gift of Mars exploration. Not merely learning about another world, but relearning gratitude for our own. And tonight, while Mars continues moving silently through darkness far beyond the clouds above, humanity remains here on Earth beneath its protective atmosphere. Cities glow softly beside oceans. Forests breathe quietly in the night. Billions of people sleep without thinking about escape velocity or radiation shielding or launch windows opening between planets. Gravity holds everyone gently against the surface of a world so familiar that its extraordinary nature often disappears into routine. But somewhere beyond the familiar sky hangs another planet waiting patiently in red silence. A world that challenges every weakness in human biology and engineering. A world difficult to reach and even harder to leave. And perhaps that difficulty matters because it reminds us that the universe is not designed around human convenience. The cosmos is vast, ancient, and governed by laws indifferent to ambition. Yet somehow, against all odds, Tiny conscious beings on one small blue planet learned enough mathematics to predict planetary motion, enough physics to escape gravity, and enough courage to imagine traveling between worlds. Maybe that is the real mystery at the center of the Mars return problem. Not simply how humanity might survive the journey physically, but why human beings continue dreaming about impossible horizons at all. Because somewhere deep inside consciousness itself seems to exist a quiet refusal to remain confined forever beneath one sky. And so Mars waits, cold, silent, beautiful in its emptiness. A distant world orbiting endlessly through cosmic darkness while humanity below continues building machines, solving equations, and imagining the long journey there and back again. Maybe that is why Mars has remained such a powerful symbol throughout human history. It is close enough to tempt us, yet distant enough to resist us. Other planets in the solar system are either too hostile, too massive, or too far away for realistic human journeys with current technology. Venus burns beneath crushing pressure and poisonous clouds. Jupiter's gravity well is so immense that escaping it borders on impossible with chemical rockets. The icy moons of the outer planets drift in darkness unimaginably far from the sun. But Mars occupies a strange middle ground. Difficult but not entirely unreachable. Deadly, but perhaps survivable with enough preparation. In some ways, Mars feels less like a final destination and more like a threshold. The first true test of whether humanity can become an interplanetary species at all. Because if returning safely from Mars proves impossible or unsustainable, then the dream of traveling deeper into the cosmos becomes vastly harder. Mars is close by cosmic standards. And still it challenges every limit of modern engineering and human endurance. The reality is almost humbling. Human civilization, despite all its technology, has not yet sent a single person beyond low Earth orbit since the Apollo era ended in the early 1970s. More than half a century has passed since astronauts last traveled to another world. The Moon itself remains only a few days away compared to Mars, yet even returning there has proven far more difficult than many expected. This reminds us that space exploration does not advance in a smooth, unstoppable line. It advances slowly, painfully, through decades of research, failure, redesign, and persistence. Every major step requires enormous collective effort from thousands of people whose names history often forgets. Engineers calculating trajectories late at night, scientists studying radiation effects, technicians testing seals and engines repeatedly, doctors researching long-duration spaceflight. Behind every rocket launch exists an invisible civilization of knowledge and labor stretching across generations. Mars concentrates all of that effort into perhaps the most difficult journey humanity has ever seriously considered attempting. And yet, despite all the complexity, the emotional core of the mission remains strangely simple. Leave Earth, survive another world, find a way home. It is almost the structure of an ancient myth. A traveler crossing dangerous territory beyond the known world, then struggling to return changed by what they experienced. Perhaps this pattern appears repeatedly in human storytelling because it reflects something deeply rooted in consciousness itself. Exploration changes people. Distance changes perspective. The farther someone travels from familiarity, the more clearly they begin to see what home truly meant all along. Mars may intensify this process beyond anything previous explorers experienced because the separation from Earth becomes almost absolute. Future astronauts may spend years knowing no human being can physically reach them quickly if disaster strikes. During emergencies, they may stand entirely alone beneath another planet's sky, relying only on one another and the fragile systems around them. That level of isolation has no true historical equivalent. Even sailors lost at sea still remained on Earth beneath breathable air and familiar gravity. Mars removes those quiet comforts completely, yet perhaps that very fragility creates a strange kind of beauty. Human beings are temporary creatures living brief lives on a small world orbiting an ordinary star. The universe itself is unimaginably larger than anything human minds evolved to comprehend. Galaxies drift through darkness, separated by distances so vast that light requires millions of years to cross between them. Against that backdrop, every human journey appears tiny, and still people continue reaching outward anyway. Maybe that persistence is meaningful precisely because success is never guaranteed. There is courage in fragile beings attempting difficult things despite understanding the risks clearly. The first astronauts who someday return safely from Mars may become symbols of that courage for generations afterward. Not because they conquered the planet. Mars cannot truly be conquered, but because they endured it, because they crossed impossible distances, survived isolation beyond ordinary human experience, and carried themselves home through the darkness once again. And perhaps when they finally return, stepping back beneath Earth's atmosphere after years away, they will notice ordinary details with extraordinary intensity. The smell of rain, the sound of leaves moving in wind, birds crossing the sky without protective suits or sealed habitats, gravity pressing naturally against muscles and bones, human civilization continuing everywhere around them beneath open air. Things ignored by most people every day may suddenly appear miraculous after living so long surrounded by machinery designed simply to imitate a tiny fraction of Earth's natural generosity. Maybe that becomes the final lesson Mars teaches humanity. Not that Earth is insignificant compared to the cosmos, but the opposite. That Earth is precious precisely because the universe beyond it is so cold and difficult. Space exploration often inspires dreams about escaping Earth someday. Yet the deeper humanity studies other worlds, the clearer it becomes that no place in the known solar system offers what Earth provides naturally and effortlessly. Oceans, stable atmosphere, life everywhere. A planet where human beings can walk outside without fear of vacuum, radiation, or toxic dust. Perhaps Mars exploration will ultimately deepen humanity's appreciation for the fragile world where every human story began. And tonight, while Mars continues circling quietly beyond the darkness overhead, Earth remains wrapped in its thin atmosphere beneath countless drifting clouds. Billions of lives unfold simultaneously across continents, glowing softly beneath the night sky. Somewhere children are sleeping peacefully while storms move across distant oceans. Somewhere telescopes are still pointed toward Mars, watching its reddish light crossing the heavens exactly as ancient civilizations once did thousands of years ago. And somewhere in laboratories and engineering centers around the world, human beings continue solving the impossible mathematics required to someday leave that distant world and come home again. Not yet, because perhaps the final and most unsettling realization about Mars is this. The planet does not care whether humanity succeeds there or not. Long after every current civilization disappears, Mars will continue orbiting the Sun in silence exactly as it does tonight. Dust storms will continue sweeping across ancient volcanic plains. Tiny ice crystals will continue forming in the thin atmosphere during cold Martian mornings. The giant canyon system called Valles Marineris will remain carved across the surface wider than the entire continental United States. Olympus Mons will still rise higher than any mountain on Earth, standing alone beneath skies no human being may ever permanently tame. There is something strangely peaceful about that indifference. The universe is not waiting for humanity. It simply exists. And yet within that enormous indifferent cosmos, conscious beings emerged on one small planet and began asking questions about the stars. That alone may be one of the strangest events in the known universe. Matter becoming aware of itself. Tiny creatures learning enough physics to leave their home world and imagine standing on another. When future historians someday describe the first successful return from Mars, they may not focus only on engines, fuel, or mission architecture. They may describe it as a turning point in human perspective. Because once humans prove they can leave Earth, survive another planet, and return safely, civilization may begin understanding itself differently forever. Earth would no longer feel like the entire human world. It would become the birthplace of a species beginning to step outward into the wider cosmos. Even if Mars remains difficult, even if settlements stay small and dangerous for centuries, the psychological boundary would already be crossed. Humanity would no longer belong entirely to one world. And perhaps that transition will happen slowly enough that most people barely notice it at first. History often works that way. Transformations that later appear monumental sometimes feel gradual while unfolding. The first transoceanic voyages did not instantly create the modern world overnight. The first airplanes seemed fragile and experimental before aviation eventually reshaped civilization completely. Mars exploration may begin the same way. A few dangerous missions, small scientific outposts, limited crews enduring enormous risks. Then slowly, decade after decade, systems improve. Infrastructure grows. Knowledge accumulates. What once seemed impossible becomes merely difficult. Then eventually perhaps almost ordinary. Yet even if humanity someday establishes permanent communities on Mars, one truth may never change. Returning to Earth will always carry emotional gravity unlike any other journey. Because Earth is more than a location in space. It is the environment that shaped every part of human biology, psychology, language, culture, and memory. Every human ancestor who ever lived evolved beneath Earth's gravity and atmosphere. Every story humanity has ever told emerged here. Mars may someday host cities, laboratories, observatories, and generations born beneath artificial domes. But Earth will remain something unique in human consciousness for as long as our species exists. Perhaps future Mars settlers will someday look at Earth the way distant immigrants once looked toward ancestral homelands across oceans. A place both familiar and unreachable at the same time. A world connected emotionally even when separated physically by impossible distance. And maybe children born on Mars generations from now will dream about Earth with the same wonder ancient humans once dreamed about Mars. Blue oceans, thick clouds, open air, rain falling naturally from the sky, birds flying freely without pressure suits or sealed habitats. To them, Earth itself may seem almost mythological, a living world overflowing with oceans and forests, while their own home remains enclosed carefully beneath protective structures against the cold red desert outside. It is strange to imagine how completely perspective changes depending on where one stands in the solar system. Tonight, however, humanity still remains entirely earthbound. Every person alive shares the same atmosphere, the same magnetic field, the same fragile biosphere drifting together through darkness around the sun. Mars remains distant, unreachable for almost everyone who has ever lived. Yet perhaps that distance is exactly what makes the planet so emotionally powerful. It reminds us that existence is larger than daily life, larger than cities and nations and ordinary human concerns. Beyond Earth lies an immense universe operating according to ancient laws untouched by politics, economics, or human opinion. Gravity curves space. Planets orbit stars. Radiation crosses galaxies. Time moves forward silently through it all. And somehow, within that vast machinery of the cosmos, human beings continue looking upward and imagining journeys beyond the horizon. Maybe that is the final answer to why returning from Mars is so hard. Because the universe was never built for creatures like us to travel easily between worlds. The distances are too large, the energy requirements too immense, the environments too hostile. Yet despite all of that, consciousness itself seems unwilling to remain still forever. Human beings continue calculating trajectories, building rockets, testing habitats, and preparing for journeys that push directly against the limits of survival. Mars challenges us precisely because it exposes the true scale of reality. And maybe that challenge is valuable, because in confronting the immense silence between planets, humanity may finally begin understanding both its fragility and its extraordinary persistence at the same time. So tonight, as Earth turns quietly beneath sleeping cities and drifting clouds, Mars continues circling the sun far away in the darkness beyond, waiting patiently beneath cold skies and endless deserts. A distant world difficult to reach, even harder to leave, and perhaps forever reminding humanity that the greatest journeys are never only about discovering new places. They are also about discovering who we become while trying to return home again.